and letting you know what's going on the rest of this week. So we have new material here today, Thursday, Friday, and Monday. And then on Tuesday and Wednesday, we'll be reviewing. And then on Thursday, you have the Chapter 5 test. And that is the last day of the quarter. You don't have school on Friday. So that is a test on 3/12. And if you know you're going to be out of town, I suggest that you take it early before you leave. I can give you the review. I'll give it to you Friday so you can work on it ahead of time if you desire. Okay. It's out of the book, so I'll just post the problems and give you the pictures and what have you. So that's fine. But if you know you're not going to be here on Thursday and want to take it on Tuesday or Wednesday, that's fine with me. Better to get it done before you leave than don't do math for 10 days and decide to take your test when we get back. So please, 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 definitely want that in before spring break. All right. Today we're talking about the sum and difference formulas, and these are formulas that I'm just going to give you the formulas. You're going to write them down, and then I'm going to show you how to use them. I will give you these formulas. These are the formulas that you need to know. I will give you these formulas on your test and on the final exam. So you don't have to necessarily memorize them, but it is important to know how they work. And students often get really confused with how it works. So please make sure that you're, doing it like I do it in notes. I'm modeling these for you very carefully. So there are formulas for tangent, but I will not ask you for the tangent. So if it comes up in your directions today in your homework, you don't have to do the tangent of the angle. You do have to do the sine and the cosine. Because if you know sine and cosine, how do you get tangent? To the sine over cosine, right? So we can get tangent just using these two. We don't have to have a whole nother formula. The other thing is that these two formulas are actually really, really easy to remember. And I'll talk about that in just a second as you guys are writing stuff down. But they have a nice, easy, predictable pattern, and you'll actually memorize them before I finish talking about it, okay? Because it's actually really easy. All right. So these are called the sum and difference formulas. This is the cosine sum because it is the sum of angle A and angle B. This would be the cosine difference because it's the difference of A and B. And again, here we have the sine sum and the sine difference of two angles A and B. Now, you'll notice for cosine, this is very easy pattern. This pattern says we're going to take cosine of the first angle times cosine of the second angle. We are changing the sign. And then again, we take sine of the first angle, sine of the second angle. You'll notice they're both cosine, cosine, sine, sine. That's what I remember. Cosine, cosine, sine, sine. And we change the sign. Whatever we started with, if it was sum, then we change the sign to subtraction in the middle, okay? If it was difference, then we change the sign to addition, all right? So cosine, cosine, sine, sine, change the sign is what I remember, okay? It's a nice pattern. All right, so much easier. Change the sign. Cosine, cosine, sine, sine, change the sign. That's what I remember for this cosine expansion. For sine, you'll notice Sine of the first thing, cosine of the second. Here the sign stays the same. Then we have cosine of the first thing, sine of the second thing. So both of these have the same pattern. Sine, cosine, cosine, sine. And what do we do? Keep the sign, all right? So these are the little phrases that I memorized, that I know for some reason for years and years and years. And it's just a pattern to expand the sum and difference of two angles. So cosine, cosine, sine, sine, change the sign. Or sine, cosine, cosine, sine, keep the sign. Let's see how we actually use that. I'm going to turn the page in a minute now. There it is. Okay. Example 1. Find the exact value of the cosine of the angle. Find the exact value of the cosine of the angle. All right. So first of all, they're asking for the exact value, and that's sort of the key here. We want an exact value of the cosine of the angle. These directions are in your homework, very close. In your homework, it says find the exact value of the cosine, sine, and tangent of the angle. You only need to do sine and cosine. Again, you don't have to do tangent of the angle. You don't need to do it, okay? For this purpose, we're just doing cosine of the angle. So what we want to do is we want to find cosine of this 11 pi over 12. Now, I could type that into my calculator. There's nothing stopping me from doing that. Cosine of 11 pi over 12. And I might do that because, well, 11 pi over 12 isn't on my unit circle. So we can get an answer. How come that answer is not okay here? Because it's exact. And this is definitely an approximation. However, on a multiple guess test, is this something you could totally do?
Yeah.
Yeah, totally. So know that when in doubt, plug it out. Okay, so now 11 pi over 12 is not on our unit circle, which makes this tricky. Because 11 pi over 12 is not on our unit circle, we need to think, hey, are there two things that we could add or subtract to give us 11 pi over 12? And yes, there's lots of things that we could, in fact, there's an infinite number of things that we could subtract or add to get 11 pi over 12. And you could do either one, and you'll end up with the same answer, which is really, really interesting. Let's do subtraction. No, let's not. Let's do addition, because that's easier to start. So we want to think, what plus what gives us 11 pi over 12? Well, I'll get you started here. 1 pi over 12 plus 10 pi's over 12 would give us 11 pi's over 12. That's great. 1 pi over 12 plus 11 pi's or 10 pi's over 12 is 11 pi over 12. Okay. But those aren't very helpful, are they?
Yeah, they're not on the unit circle.
They're not on the unit circle either. Okay. All right, attempt number 2. Cosine of 2 pi over 12 plus 9 pi over 12 gives us 11 pi over 12. What's nice about these? They reduce. They reduce, and when you reduce them, they're on the unit circle. So that's really, really handy. So you see what I did there? I'm basically creating a list of things. Let me, on a side note here, because a lot of students ask this first period, what if it was like, I don't know, negative 7 pi's over 12? subtracting, or negative 7 pi over 12. We want to think of two things that would give us negative 7 pi over 12. 2 pi over 12 minus 9 pi over 12 would give you negative 7 pi over 12, right? And it reduces. That's nice, right? And there's lots of those options. We can just go down the line. I could do 3 pi over 12 minus 10 pi's over 12. That also gives me negative 7 pi over 12, and it reduces. There are an infinite number of these possibilities, right? Okay, so keep that in mind. If it's negative, you can subtract pretty easily. All right, these reduce, so we're going to reduce them. Cosine of pi over 6 plus, here this reduces to 3 pi over 4. Very good. Most students, when they run into issues, it's because they reduced incorrectly. So be careful. All right, what we have here, I'm going to color code this, so hopefully it'll be nice and clear. I have a first angle here. This is angle, the A thing on the formula, the first thing. And here I have my second angle, and that's the B angle. And we have a plus sign in the middle. And so this follows our pattern for the cosine sum formula. What was the pattern for the cosine sum? Cosine, cosine, sine, sine, change the sign. Okay? So that was easy. Now, to figure that out, that will be, we can expand it, and I call it an expansion because it is getting larger. We want cosine of the first angle times cosine of the second angle, change the sign, minus sine of the first angle, pi over 6, times sine of the second angle, 3 pi over 4. Please don't skip that step. I know you want to. Please don't skip it, because when you skip it, you will get so messed up and it'll be so weird and mathematically incorrect, which just drives me nuts, okay? Once you've expanded, then we can actually evaluate using our angles, circles and dots here. My first angle was pi over 6. That's taking pi and dividing it into 6 wedges. Right here is pi over 6. What's that ordered pair? Good. Radical 3 over 2 up a half. My second angle was 3 pi over 4. So that's taking pi and dividing it into 4 equal wedges. And we want 3 of them. So there. Oh, I missed. Just kidding. Sweet. Okay. There is 3 pi over 4. What's the ordered pair at 3 pi over 4? Negative radical 2 over 2, up radical 2 over 2. Very good. All right, so now that we remember that, now we can actually evaluate these trig ratios here. Cosine at pi over 6 is what? Radical 3 over 2. Cosine, sine, alphabetical. So radical 3 over 2. Then, what is cosine at 3 pi over 4? Negative radical 2 over 2. We have the subtraction sign. Then we have sine of pi over 6. 1/2. And last, multiplied by sine at 3 pi over 4. Radical 2 over 2. All right, so that's evaluate. When we evaluate, then we get those ordered paired ratios, okay? Now it's just multiplying, which turns out to be the part that students mess up the most, okay? We're multiplying fractions. How do you multiply fractions? Straight across. straight across. So straight across here, radical 3 times negative radical 2 is negative radical 6 over 4. 2 times 2 is 4. And then we have a subtraction sign. 1 times radical 2 is radical 2. 2 times 2 is 4. This is a great answer, but your book is probably going to condense it a little because they have a common denominator. So negative radical, whoops, I wrote that. Negative radical 6 minus radical 2, all divided by 4.
So it's not going to be like
No. Yeah, that's just like an X and a Y. Totally different. Yeah. And follow up to that question, Jay, that you just asked. If I had 3 radical 5s plus 6 radical 5s, these would be like radicals. So that would be 9 radical 5s. Does that make sense to you? It's the same as 3x plus 2x. The radicals have to match in order to combine them. Okay? All right. I can type this into my calculator very carefully. If I put parentheses around the numerator, negative radical 6 minus radical 2, all divided by 4, gives me negative 0.9659 ... And that is what we estimated at the beginning. So our answer is absolutely correct. Okay? All right?
so
Yeah.
there's a way that we can just like check ourselves.
Yes. So absolutely that's how you would check. Because I'm going to give you an exact answer. So yes, that is allowed. All right. Questions on expanding using our sum or difference formula? What's the cosine pattern? Cosine, cosine, sine, sine. What's the sine pattern?
Cosine, sine, sine.
Sine, cosine, cosine, sine. Okay. So example 2. Find the exact value of each expression. Example 2. Find the exact value of each expression. Are they the same thing?
No.
No, they are not. This entire example and the first question on your homework is to illustrate that sine of 7 pi over 6 minus pi over 3 does not equal sine of 7 pi over 6 minus sine of pi over 3. Why would people think that they are equal to one another? Distributive property, okay? You cannot distribute functions, all right? We can distribute numbers, we can distribute variables, but not trig functions, okay? It's not a number we can distribute. Jay.
No, I was going to just like point out that like 7 over 6 is the same as 5 over 6. Like that ratio.
Wait. Say that again.
For like B, for like the sine of 7 over 6 would be like
Yes, negative 1/2. Yes. Good. Do you want to, we can start with B. Should we start with B or A? Because they are A. Oh, okay. All right.
Go B.
All right. So I hear you do it in order. Yes. So this first part here is in the format of a sine difference formula. What is our pattern for the sine difference? Sine, cosine, cosine, sine, keep the sign. Sine, cosine, cosine, sine, keep the sign. All right, so I have my first angle here is 7 pi over 6. My second angle is pi over 3. Now you'll notice this was a subtraction. I am keeping the sign, which means I don't have to worry about it. The B, the second angle here, is not a negative pi over 3. Does that make sense to you? Okay. It would be the same if you wanted to. We could do the sine of 7 pi over 6 plus a negative pi over 3, where the A is the 7 pi over 6 and the B is the negative angle pi over 3. But that would use the plus. And does that make sense to you? Do you get what I'm trying to tell you? Okay. You'll get the same answer, just a slightly different way. Okay. But here, we would use the plus formula, and our angle would be negative. So you have to be a little more careful. But here we get to ignore that and just keep the sign in the formula. All right. So to expand this is going to be sine of the first thing times cosine of the second thing minus cosine of the first thing times sine of the second thing. Please write it out. Okay, I know you don't want to. All right, 7 pi over 6. That would be taking pi and dividing it into 6 wedges on the top and on the bottom. And 7 of them means I'm right down here in quadrant 3. What's that ordered pair? Good. Negative radical 3 over 2, negative 1/2. Very good. In red, my pi over 3 angle is taking pi and dividing it into 3 large wedges. And pi over 3 is one of those. What ordered pair is pi over 3? 1/2 and radical 3 over 2. All right. So now we can evaluate what is sine at 7 pi over 6. Negative 1/2. What is cosine at pi over 3? Positive 1/2. Good. Minus. What is the cosine value at 7 pi over 6? Negative radical 3 over 2. Good. And the sine at pi over 3? Radical 3 over 2. Remember, they go cosine, sine, alphabetical order. Okay. And then we just get to multiply straight across. Negative 1 times 1 is 1. 2 times 2 is 4. Sorry, negative 1. Now, in the back end here, is our result negative or positive?
Oh, we don't positive.
It's going to turn positive, right? Yeah, because all these are multiplied together. So positive, negative times negative is positive. Radical 3 times radical 3? Radical 9. What is radical 9? Just 3. Okay. Over 4. Oh, interesting. What is negative 1/4 plus 3/4? 2/4, which is 1/2. Are you kidding me? It is.
Oh my God.
I know, we did all that work and it was 1/2. If we plugged it into our calculator first, it would have given us 0.5 and we're like, oh, okay. All right, so, well, that cleaned up really nicely. Over here, sine of 7 pi over 6 is negative 1/2. Good. Minus sine at pi over 3, radical 3 over 2. Okay, well, that's just not the same at all. Negative 1 minus radical 3 all over 2. Very, very different. Okay, so can you distribute sine? No, don't do it. It doesn't work. Okay. Questions on this? What's the pattern for cosine?
Cosine, cosine, sine, sine.
Cosine, cosine, sine, sine. What's the pattern for sine?
Sine, cosine, cosine, sine.
Sine, cosine, cosine, sine. Keep the sign, yes. Okay, very good. Keep the sign. All right. You do not have to write all these directions. This one is ridiculously easy. All right. How about we just write condense? Condense and then find the exact value. So just write that. Example 3, condense, but find the exact value. These, all my directions, I try to come from your homework, right? So when you read the homework directions, you can align it with our notes. But often your book is exceptionally wordy. Write the expression as the sine, cosine, or tangent of an angle. Then find the exact value. Oh, you recognize a pattern here, right? Sine of pi over 18, cosine of 5 pi over 18.
This is the sine plus
This is the sine sum pattern. Good. And you can recognize that, obviously, sine, cosine, cosine, sine. Keep the sign, okay? So it fits our sine sum pattern just perfectly. So we know that that came from the sine of the sum of two angles. Well, what are our two angles here? Pi over 18 and 5 pi over 18. The pi's over 18 were completely useless, right? Because that's not on my unit circle, so why would they ever do this? I don't know. This I can add together. They have a common denominator. That gives me 6 pi's over 18, which reduces to pi over 3. And what is the sine value at pi over 3?
radical 3 over 2.
Radical 3 over 2. All right. So you have a few easy problems like this where it's literally condense it and then go. All right. So really that's just, can you recognize a pattern? Yeah, it's not. But like if I didn't show you this, you would have been like, what? Jay.
So what do we do if there's not a common denominator?
So you would need to get a common denominator if they weren't already. And you can do that and reduce and it'll work out because it's a math book and everything always works out like it's supposed to. Okay. All right, last one. In 3 minutes, I know it seems long, but this is the most important one that your teacher's going to test you on, so pay attention. Uh-huh. Because the other ones,
Are easy.
you could do just on your calculator, right? This one, you can. This one, you have to show mathematical knowledge. Okay, so example 4. Find the exact value indicated under the given conditions. Yeah. Sine of angle U, sine of some angle U is 5 over 13, and that angle is in quadrant 2. And tangent of angle V is negative radical 3, and angle V is also in quadrant 2. And what we want to do is we actually want to find the cosine of the sum of the two angles, which I don't know. They are sort of unknown. All I have is some extra information. This cosine of U plus V, that's telling me to use the cosine sum formula. And what is that cosine sum formula pattern? Change the sign. Cosine, cosine, sine, sine, change the sign. So we know we're going to have to use that formula expansion, which we'll do in just a minute, because I need some more information. First of all, anytime they give me a trig equation, what is our job? Draw a triangle. There's always a triangle associated with it. So we are going to draw angle U in quadrant 2. So I'm going to draw my angle U ending in quadrant 2. There's U. What do we do when it ends in quadrant 2? How do I make a triangle? Drop an altitude, always, always. And that creates my little reference triangle, U prime. I'm not going to make it. I'm going to stop the video and